In this video, I'll be covering question 6, part B from the 2018 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, and C all in their own individual videos, so if you want to see my other solutions, please check out my other videos. Alright, so looking at B, B says let y equals f of x be the particular solution to the given differential equation. So differential equation is just fancy math talk for derivative. So there's our given differential equation. And they're telling us that we have this initial condition here. When we plug in x for 1, we get out a y value of 0. And what they want us to do is they want us to write the equation for the line tangent to the graph at x equals 1. And once we do that, we're going to use that equation to approximate f of 0.7. So when you're going to find the equation of a line, this really goes back to the same way you found the equation of a line back in an algebra class. You're going to be using the point slope form of a line. So that looks like y equals m times x minus x1 plus y1. I know there's other versions of this that have the y1 on the other side. You're always going to want to move that y1 over. So if you're going to memorize point slope form, this is by far the quickest and easiest way and best way to memorize your point slope form. As you come through here, we just kind of want to remember what these pieces mean, right? So the m is our slope, which back in algebra, you do a y2 minus y1 over x2 minus x1. But now that you're in a calculus class, you would just take and plug your value into your derivative. Your derivative is what gives you the slope. And when we're talking differential equations, our derivative is known by that equation dy dx. So we need to find the slope. And then x1, y1 here, that's a point on the graph. So that's x1, y1, the point on the graph that we care about. So as you look through, kind of the easiest thing to grab real fast is your point. So what we've got right now is f of 1 equals 0. So that is the x value. So that's x1. And this would be y1. Now to find our actual slope, we're going to use that derivative, that differential equation up there. So dy dx equals 1/3, oops, I don't want the parentheses yet, x times y minus 2 squared. Well, what we need in this is we need an x and a y to plug in there. And oh crazy, what do we have? We had, when we grabbed our point, our x and our y. So you're just going to use those same two values. A lot of times you'll see them notate it with this evaluated at, and then you would put the point 1, 0. That's our x, that's our y. Plug into the equation, you'd get 1/3, and then our x value on that is 1 times our y value is 0 minus 2, and then squared. Cleaning that thing up, 1/3 times 1 gets us 1/3. We'd end up with negative 2 squared there. Negative 2 squared would equal 4. So 4 times 1/3 is going to get us 4/3. So that is now our slope. That's our m that we need for our point slope form. So we've basically completed the point about finding the equation of the tangent line. We're just going to plug everybody into the point slope form. So y equals m, which is 4/3 times x minus x1, which is 1, plus y1, which is 0. And then you don't have to simplify this, but if you wanted to, you could kind of, there's no reason in having that plus 0. Sort of the most I would do is say y equals 4/3 times x minus 1. So that is the equation of the tangent line right there. They also refer to this as your linear approximation formula. They've got about 3 different names that they like to call this. It's the tangent line approximation formula. It's the equation of the tangent line. It's also your linear approximation. And so what this is this equation here approximates our original function f of x. And then what we'll do is use that equation to estimate 0.7 here. And so out of there you would get f of 0.7 is approximately 4/3 times 0.7 minus 1. And because of this tangent line approximation that they want us to do, that's why it's usually nice not to multiply this thing out, because this math becomes a little bit easier to do. So from there you would get that this is 4/3 times 0.7 minus 1 would get us negative 0.3. And from here, we'd have to go ahead and sort of put this together. I think they would almost let you leave it like that, but if you needed to go a step further, you would want to sort of say that's negative 3/10, is what you're reading there. Remember to read your decimal, and that tells you that this would be -3 over 10. And from there, we can go ahead and simplify that down. This 3 is going to cancel with that 3. I can pull a 2 out of the 4 and a 2 out of the 10. And what that's going to leave me with is an approximation of -2 over 5. So f of 0.7 is approximated by -2 over 5. The key to this is just remembering that when you want the equation of a line, it's always going to run through the point-slope form. And the only real unique thing about calculus is the fact that your slope comes from your derivative, or if they use their fancy math talk, your differential equation. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.